Going here. All right, so we're going to do project 3 today. Alrighty, so let's head over. Share my screen, that might help, right? There we are. Okay. Okie dokie. Alrighty. So, what you're going to do in this experiment is you're going to take 2 slices, roughly equal size, of a potato. Okay? You're going to plunk one in fresh water, okay, from the tap, and another in salt water. All right, and you're going to leave them for, I believe, 24 hours. All right. So, question 1 just goes over what do you think is going to happen? Which potato slice do you think will change the most? All right. So, what do you think will occur during this experiment? All righty. If like you could say something like, hang on, I got chords galore over here. There we go. Ooh, that's much better. Alrighty, so if the potato is in salt water, then the water in the potato should leave, should exit the potato. Okay, something to that effect. Or if the potato's in fresh water, um, then it will change the most. So just a hypothesis. It does not have to be correct. All right, because most hypotheses in science are wrong. All right, so as long as you put give me a hypothesis, you will get the 20 points on that question. Okay. All righty. So next, explain the movement of water in an isotonic solution. So an isotonic solution is we talk about the Goldilocks principle, right? We all know the story of Goldilocks. The porridge was too hot, it's too cold, it was just right. All right. Isotonic solution is the just right. Okay. There is an equal amount of water and solutes or stuff, okay, inside and outside the cell. Okay. Water and solutes still flow back and forth, but there's no change in the cell itself. Alrighty, so there's an equal amount of water and solute in the cell, equal amount of water and solute. You can think of solute like salt. All right, it's actually just any type of solid matter, but we can just use salt for this example. So there's an equal amount of water and salt in the cell, equal amount of water and salt on the outside. Okay, stuff still flows, but there's no change. Okay. All right. So where students get tripped up is the difference between hypotonic and hypertonic. Okay. Hypo kind of, if you look at just hypo kind of looks like the word hippo, like a hippopotamus. Okay. So if we think of a hippopotamus as being swollen and being, kind of big and fat, right? That's what's going to happen to the cell. All right, in a hypotonic solution. So water flows into the cell, making it larger, like a hippo. Okay, big and round. Okay. The reason for that is that there are more solutes, more salt in the cell than there is outside. Okay. There's less water in the cell than there is outside. So there's more solutes and less water, so water is going to go into the cell. All right, and the cell's going to expand. Hyper is the exact opposite. Okay, water is going to leave the cell, and the cell is going to shrink. Okay. So to describe how a cell would react, there's no change in an isotonic solution. Hypertonic, okay, the cell shrinks because there is more water inside the cell. in a hypertonic solution. There's more water inside the cell than outside, so water is going to leave and the cell is going to shrink. Hypo, like hippo, the cell is going to swell because there's less water in the cell than there is outside. There's more water outside, so water is going to go in and swell up the cell. All right? Okay, and that is question 1. All right, that's it. Boom, lesson 11's done. Okay. Okay, we'll talk about this difference between osmosis and diffusion, active, passive, and active transport during your Adobe on Friday. Okay, so my project 3. Okay, so lesson 12. All right, so give me the steps of the experiment that you're doing. Okay, include measurements, include how you're going to maintain lab safety, cut away from yourself, use a cutting board, wear proper clothing, tie your hair back if you have long hair, that kind of stuff. Alrighty. Give all these the steps. So you're going to get 2 equal slices of a potato. Okay, so I should be able to go home and do the experiment based on what you're telling me. So I'm going to get 2 slices of a potato. I'm going to put each slice in a half a cup of water. Okay. And in one of the cups, I'm going to add, I think it's a teaspoon of salt, and stir it up. Okay, so you have a fresh water and a salt water cup. All right, put 1 slice in the fresh water, 1 slice in the salt water, put them on the counter for 24 hours. That's it. Okay. So, includes the question the lab will answer. Alrighty. Which has a greater concentration of water, a saltwater solution or a potato? So, which has more water in it? Okay, the potato or the salt water? Okay, so you're going to see which way the water flows. The water is going to flow, it flows down a concentration gradient, meaning that, think of it as like a playground slide, right? So you start off at the top, give yourself a little push, and after that, you don't have to do anything to get to the bottom. Alrighty? That is osmosis in a nutshell. Osmosis is just the transfer of water across a membrane. Alrighty? So there's no energy involved. Okay? It's like another analogy you can use is being in a crowded elevator, right? So you're in a crowded elevator, boom, it gets to the lobby, elevator doors open, everybody's squished in like sardines, and the elevator door opens, which is in this case the membrane, and everybody goes out into the lobby where there's more space. Okay? That's what osmosis is. Okay? The water is just going to where there's more space. Alright? So, where the water is going to go where there is less of it. There's more space for the water molecules to do their thing. Alrighty? So you're trying to determine which has more water, the potato or the saltwater solution. Okay? And I'll tell you how you're going to figure that out here in a few minutes. Okay, so click on the hot pink tab. If you don't have the materials, if you can't find the potato, or go to the store, or get to the store, you don't have a ride. Okie dokie. Osmosis. Let's go to View, Present. Okay, so osmosis. Alrighty. So you're going to need a potato, knife, 2 bowls or cups. Okay. A total of a cup of water, half a cup in each bowl, and a tablespoon of salt. I said it was a teaspoon, it's actually a tablespoon. Okay. So, just so you guys know, and obviously this is an English, a tablespoon's not metric. Alrighty. That's an English system of measurement. If you only have a teaspoon is, 3 teaspoons is a tablespoon. Alright, so if you don't have a tablespoon at home, just put in 3 teaspoons. It's the same thing. All right. Label your bowl or cup. Boom. Okay. So you mark a bowl with plain water, one with salt water. Put a half a cup of water in each. Okay. And then in just one of the bowls or cups, you're going to put the tablespoon of salt. Stir it up. Okay. So now you have fresh water, and now you have a saltwater solution. Okay. So you're going to have 2 equal slices of potato, so cut towards the middle. Alrighty, so 2 equal slices of potato. Plunk one slice in the fresh water, another in the salt water. Okay. And just leave it for 24 hours. You put both on the counter. You remember in the yogurt one, you had one on the counter, one in the fridge. You don't have to do that this time. Okay, just put both on the counter and just walk away. Alrighty, for 24 hours and come back the next day. Alrighty, so here's a little, okay. So roughly the same size potato pieces. Okay, fresh water, salt water. You are going to want to skin the potato. I did not say that in the directions. You are going to want to skin it. Okay, peel it. Alrighty. So, after 24 hours, what do the potatoes look like? Are they firm or are they soft? Okay, so, in salt water, okay, you can see after 24 hours, the potato very bendy. Okay, bends very, very easily. The reason for that is that when you put the potato slice in, it was probably firm, right? Because potatoes are kind of hard if you don't cook them first. So you plunk it into the salt water, you take it out. What happens is that the salt water has so much salt in it that there's the concentration of water in the salt water solution. There's less water in the salt water. There's more water in the potato. Okay, so the water from the potato is going to leave. Okay, going to leave the potato and go into the salt water. So when the water leaves, the potato in the salt water is going to get, it's going to shrink a little bit, and it's going to get flexible, bendy. Okay, it might turn brown even. All right. Okay, so you can actually see the yellowish potato juice in the saltwater bowl right here. Okay, this is the freshwater bowl. Looks different color-wise, doesn't it? Okay, the saltwater bowl is yellow because the potato juice, the potato water, leaked out and went out into the bowl. All right, the freshwater bowl down here didn't have that problem. We'll talk about that on the next slide. Okay. Alrighty. This is the freshwater potato. Alright. Very, very firm. So what happens is, in the freshwater potato, water actually went into the potato. Alright, so there was more water or more water concentration in the freshwater than there was in the potato. The potato had less, the freshwater potato piece had less water inside of it. So more water went into the potato, and it actually becomes firmer. It gets really hard. Okay, this can't bend. You can see it's super straight. All right. Okay, so to repeat. Okay, in a saltwater potato, in the saltwater solution, you have a hypertonic solution. All right, because water exited the potato, went into the salt water. Okay, there was less water there was more water in the potato. So water left the potato and went into the salt water. Hypertonic. Okay? In the freshwater potato, it's hypotonic. Right? Hippo swells up. Alrighty? So water goes into the potato because there's less water in the potato than there is in the freshwater solution. Alright? So water's going into the potato in the fresh water. So that is a hypotonic solution. Okay. Pardon me. So Using observations, determine if the solution was hyper or hypotonic. Okay, so in a high solute concentration, high salt, water is going to leave the potato. Okay, this is the salt water. This is hypertonic. All right. So there's very little. There are some solutes, some particulates in tap water. All right, you do have some metals and minerals in tap water. All right, it's still safe for you to drink. So it's very low solute, or no solute even. Okay, if you have like a reverse osmosis system at home. Okay, so water is going to enter in the freshwater potato, and this is hypotonic. Okay, so salt water, hyper. Freshwater is hypo. Alrighty. Okay. That's what that means. Okay, so let's go back to our course player. So which potato slice changed the most? Probably the saltwater potato, right? Because it got bendy and soft, right? Maybe even change. Some potatoes change color. Depends on how old the potato is. Okay, some get a little yellowish or brown. All right, if yours doesn't change color, don't worry about it. Okay, what you want to see is that it gets soft. Okay, so you're going to tell me what happened to both potato pieces. Don't just talk about the saltwater potato. Talk about the freshwater potato too. All right. So, what happened to the potato piece? Okay, what happened to both? All right, the saltwater potato piece got softer. The freshwater potato piece became firm and hard, something like that. Okay, so did they swell, shrink, or stay the same? The one in salt water should shrink and become bendy and flexible, and the one in freshwater, plain water, should swell. Okay, become even firmer, even harder. All right. So make sure you're describing both potato pieces for lesson 13. Okay. Alrighty. So let's go to osmosis. Okay. So did the potato slide? Now here in lesson 14, you're just talking about the saltwater potato. Okay. So you're just talking about the saltwater potato here for lesson 14. So did the potato slice gain or lose water? It lost water, right? Because water exited the potato. It diffused, since it lost water, water diffused out of the potato piece. Okay. Why did it diffuse in the direction that it did? There was less water, less water concentration in the salt water was lower, okay, than in the potato. The potato had more water in it than the salt water did. Okay, so the water went out of the potato and into the salt water. Okay, potato slice had a higher concentration of water. That's why the water left. Okay, the saltwater potato was in a hypertonic solution, right? Because it got smaller. Hypo, right? Like a hippo gets fat. Okay. All right. So for this portion, the next portion of your answer, describe errors that occurred and how they affected the experiment. If your experiment went off without a hitch and it was perfect in every way, describe what could have happened. Don't just tell me nothing, I had no errors. Well, great, that's wonderful, but what could have gone wrong? And how would that have affected your results? Like, for example, did you not use enough water? Okay. Could you have used a teaspoon of salt instead of a tablespoon? Okay. Not as much water would have gone out of the saltwater potato in that case, right? Because there was less salt. All right. So there were, the potato pieces might not have been the same size. All right. So something that could have gone wrong. If something did go horribly wrong, tell me about it. Okay, this is what happened. This is how it screwed up. So that way this is what I would have changed in the future. That way I know you understand the experiment, where you went wrong, and how to fix it. If nothing went wrong, great. Just say, the few examples that could have gone wrong. Potato slices could have been different sizes. The salt, you could have put the wrong measurement of salt in. You could have used either too much or not enough water. All right, any of those could have been an error on your part. All right. Kidoki. Okay. And that is actually it. There is no lesson. There's no. It's just lessons 11 through 14. There's no project in lesson 15. Okay. Does that make sense? And I am recording this, so I will send you the recording as well. Okay. Alrighty, Jacqueline. Stop the recording. Seacrest out.